lesson today. This is Mr. Whitford. Very excited to have you as we continue to work on Unit 2 in our Math 8 unit lessons. We're going to be talking about today proportional relationships with equations as we talked about last lesson, proportional relationships with tables. So if you're joining me, feel free to open up your packet to lesson 2.3. If you are online, you can go to your Google Classroom page and look at the assignment area and also open lesson 2.3 for proportional relationships as well. All right, please join me with looking at the worksheet. As usual, I'm going to give you a few minutes to be able to look at the bell work. And as you see, it says here, fill in the missing numbers on the tables below, and then identify the constant ratio. Remember, we talked about constant ratio, also known as our unit rate. Identify the constant ratio, and then begin to fill in these missing numbers, as well as even the missing values on the tables provided for you. Take this time, pause the video if you need to. All right, I'm glad. I hope you had enough time to be able to complete that. Remember, this is a review of the content that we went over in lessons 2.1 as well as lessons 2.2. So feel free to go back and watch the videos for lessons 2.1 or 2.2 if the bell work was a little tough for you. But let's go in and I'm going to begin to fill it in to be able to help you. The first thing you want to do is identify the constant ratio. And as a refresher, remember the way we find the constant ratio is we do y divided by x. We do y divided by x. In this case, we're going to do, and let me just put the x and y values here. We are going to do 60 divided by 20. And we're going to come out to identify the constant ratio here is 3 to 1 or 3 or over 1. Okay, what is this telling us? This is telling us that the y is increasing by 3 as the x is increasing by 1. So the y is increasing by 3 as the x is increasing by 1. We're going to use this information to be able to find the missing numbers. So I'm going to start off by identifying this one here and saying, okay, x over 6. And I'm just using x as the variable for this unknown. This has to equal 3. So whenever we're looking for the numerator number, we're going to take the denominator and multiply it by our constant. 6 times 3 is going to give us 18. When I go to find the second missing number here, we're going to do 42 divided by x, and x is just representing this blank spot. That has to equal 3. So we're going to ask ourselves, okay, 42 divided by what number is going to give us 3? And the way we figure this out is we're actually going to divide 42 by 3. And when we divide 42 by 3, we end up getting 14. Okay, we end up getting 14. And lastly, we find the last number, similar to how we found the first number, x over 10 has to equal 3. And we're saying to ourselves, what number divided by 10 is going to give us 3? Or you multiply the denominator times our constant, and we get 30. So that's how we fill in the information on the first table. Now, the second table, as we go to approach the second table, we're going to say to ourselves, okay, what is the important information? 30 bicycles every 2 hours, okay? They want to know how many bicycles produced each hour. So if I were to write that, it would be bikes over hours, bikes over hours. And remember, our constant ratio here is y over x, which tells us that bikes is going to be our y value, whereas hours or hour is going to be our x value. Okay? Once again, our x is always the first row. Our y's are always the second row. We're looking for each hour, which means at 1 hour, how many bikes are produced. They told us that 30 bicycles, and I'm using the information they gave us now, 30 bicycles every 2 hours. So now I want to figure out how many bicycles for 1 hour. And once again, we find the unit rate by just doing y divided by x. So 30 divided by 2, and that gives us 15. So we understand that this means that there are 15 bikes produced each hour. Okay, and this is how we fill in our tables, by identifying the constant, identifying the unit rate, and using that unit rate to be able to actually calculate the remaining data values, or to be able to find the unit rate itself per hour. Okay, Now, once again, I'm gonna mention this as a tool. If you need help with this, and this is a little still tough for you, I would recommend you go back and you watch lessons 2.1 and 2.2 to get a better understanding of how to fill in table values with the constant, as well as how to fill in the information to identify the unit rate. Okay. Now, today we're going to be talking about proportional relationships with equations. How can we use data from a table to form an equation? So right now we have tables, and we have tables, but we want to say, okay, well, how can I turn the data from a table into an equation? How can I turn that into an equation? And that has a lot to do with the vocabulary we're looking at here. The constant of proportionality. We already talked about the constant. We know this equation down here, k is equal to y over x. Now the constant in this case is represented by k. Our constant is represented by the letter k, right? And that's how we identify the constant. We know it's y over x. But in addition, I want you to know the proportional relationship can also be described in the equation form of y is equal to k times x, where k is called the constant of proportionality, as we have talked about in the past, right? We have talked about this in the past. Okay, and I'm almost done here. All right, sorry if it's a little sloppy, but you see exactly what I'm writing. This equation, y is equal to k times x. And if I was you, I would take a highlighter and I would just go over this and I would highlight this equation. This equation is very important. We have used k is equal to y over x many times already, but this new equation, y is equal to k times x, is going to be absolutely important for us today. So what I want to do is this, is I'm going to model for you one of each of these practice problems, as well as even the modeling section where I'm going to practice a model 2 problems for you. And I want you to be able to fill in the rest. So for example, independent practice 1. Let me model for you the first one. So if we scroll down, you'll see that they want us to create equations and find the missing values. They want us to find the value of y equaling, of y when x is 2, right? They told us x is 4, y is 12. So what is y when x is 2? And right now, honestly, even in class, I may even give you a few minutes, and I probably gave you a few minutes to be able to calculate y on your own, because I think you could do that. If you did y divided by x here, you could find the constant and then multiply that to find this missing number. You can even create a table if you wanted to be able to identify, well, what do you mean, Mr. Wilford? Let me show you. If you wanted to, you could have created a table from this data. And the table would look something like this, right? I'm sorry about that line out there. X and Y goes here. And maybe you would say, okay, when X is 4, right, Y is 12. When X is 2, oh, sorry, and I put this in the wrong spot. Forgive me. Let me actually delete it and redo it. Okay. When X is 4, Y is 2. So when X is 2, Y is what? And we could use the constant of proportionality to say, okay, well, Y divided by 4 gives me 3, right? So this is what I need. So when I do X over 2, because X is this blank, right, over 2 has to equal 3. So 2 times 3 would give us 6. And we can say, okay, well, Y is 6 using the information we already have. But I want you to notice what I did. I put it in a table form. I identified my K, and I know that K is equal to 3. Now, if you remember above, and I'm going to scroll up a little bit, because they want us to write the equation here, and I'm going to show you. Y equals K times X. Y equals K times X. If I was writing the equation, the Y does not change. Neither does the X. The only thing that's going to change here that we need to include in our equation is K. And K in this case is 3. So the equation that we would write is Y is equal to 3X. Notice we identified what Y was, right? And we was able to use a table form to figure out the missing value of Y, to figure out what K was, and then to also write this equation Y is equal to 3X. Do me a favor and see if you could figure out what K is for both of these, and then what the equation is. All right, once again, I'm going to give you some time right now. Pause the video to see if you could figure that out. I'm actually not going to finish going over this with you because I do want you to do that in class. But take a moment to pause the video now and see if you can figure that out. All right. I'm hoping you got a chance to pause it. Once again, I won't be going over that with you, but please, if you need to rewatch how I did the first one, please do so. Now, I want to go over this modeling area here, okay? These are word problems, and there's a good amount of chance that we're going to see word problems and be able to change them. Our goal for today, believe it or not, will be to analyze word problems, analyze equations, and analyze tables, right? To be able to tell me the equation of these different proportional relationships. So today is a lot that we're doing, and it may even extend to 2 periods, okay? Given the proportional table below, let's fill in the missing numbers. And then let's state an equation for y in terms of x. The first thing I would recommend you do is identify k. Remember, k is y divided by x. Identify what your k is. So in this case, I'm going to use the only information they gave me. And remember when we did this last time on the tables, I said, okay, first figure out what you know. And what we know here is we know that x is 4, y is 6. It's the only data here that's fully filled in. So I'm going to find my constant by saying, okay, 6 divided by 4. Now, if you have one of those, or if you want to use your calculator to reduce this and put it in simplest form, and remember, simplest form is saying, let's simplify the fraction. If I were to simplify this fraction, I'm saying, okay, let me divide them both by 2. I'm going to divide these both by 2 because they're both even numbers. And what I end up getting is I actually get 3 over 2. Now, what does this mean? This means y increases, and that's increases by 3. Remember, the top value is y. The bottom is telling us that x increases by 2. Okay? So when I look at my table, does x increase by 2? Yeah. -2 plus 2, 0. Plus 2 is 2. Plus 2 is 4. And if you want, I mean, I could do like something like this and just put the plus 2 on top of it so you can see that they are increasing by plus 2. But what does that mean about the y? The y increases by 3. So if I go here, I should be able to add 3, right? And let me just change up the color so you can see it. Right? I should be able to say, okay, well, if y increases by 3, right, and that's a 3, 6 plus 3 gives me 9. Increases by 3 gives me 12. Now I can obviously go backwards and say, okay, well, this must be 3. This must be 0. This must be -3. All right? That's how we would fill out a table just in a normal form without any information here, without any full data, right? And I want to point out one more thing before I go to one more problem for you. Did you notice that this is 0, 0? Right? This is a good indication that this particular table is proportional. So I'm just going to make a side note here, right? That whenever we see 0, 0, and we can identify that there is a constant, right? This is a good hint that this table might be proportional. You see 0, 0, that's a good hint, it might be proportional. Is it always the case? No, because a table could have 0, 0, but then not have a constant. But if you see 0, 0, and you can identify the constant, then say, yes, this is a proportional relationship. Let me go on to do modeling B, so that way we can then be able to dive into understanding this from a word problem perspective. Now, Megan earns $12 an hour at, let me just get rid of this because I can't actually see it, at her part-time job. Show that the relationship between the amount she earned and the amount of hours she worked is a proportional relationship. So earned hours. You want us to show that in terms of a proportional relationship and then write an equation. Okay, oh, I actually forgot to write the equation for A, and which is what we're doing, right, today. Y is equal to, right? This is our constant, so K times x. I apologize. I meant to write the equation here. I know we're doing a lot today. We're doing a lot today between writing equations, filling in tables, identifying the constant. There's a lot, right? But our first goal will be to identify the constant. Now, in B, we first need to figure out, okay, well, how do we fill in this table? This table is going to be like this. We are going to fill in this table by recognizing we're doing earned. Right, we're doing earned over hours. We're doing earned over hours. First thing I want you to identify is what are you doing? What does this look like? Now, the problems that you're going to deal with will tell you specifically earned per hours. Mine did not, but I recognize the number of hours, right? I recognize it says earned here, and the next thing it says is the number of hours. So that tells me earned per hours, okay? So remember when we deal with K, which is Y over X, we're going to recognize that Y is our earned information. So I'm going to fill this in here and say this is earned. Whereas X is hours. X is hours. Okay? Now they want me to figure out the relationship value here. Now I'm going to fill out what I know. What I currently know here. It says Megan earns $12 an hour. $12 an hour. So that means that she earns 12, right, over 1. Right, 12/1. What does this mean? This means that Y is going to increase. Y is increasing by 12. Y increases by 12, whereas X increases by 1. This is important for us to know. Important because when we find that constant, like for example here, when we make the table, notice that the table here, it started off with 0, 0. So if you want, start your table with 0, 0. You notice it's proportional, that's fine. Start off with 0, 0 if you want. Okay? If you want to start with 0, that's fine. Another thing you could do is if you want, you could start this off with 1 in the hours and 12 in the earned. That's perfectly fine as well. I think I like for you to start with 0, 0 to remember that our proportional relationships start at 0, 0. Okay? Then what I want us to do is realize, okay, well, X is increasing by 1. So 1, 2, 3, 4. Notice in our past one, the X was increasing by 2. So it went 2, 4, 6, 8. Our earned is going to be increasing by 12. So I'm going to go 12, 24, 36, 48. Now, that's my table. My table's filled out. That's all good. I have my table fully filled out, but now I'm still missing something. I'm missing my equation. What is the equation here? Remember, the equation that we're looking at today is y is equal to k times x. K is your constant. K is telling you what's happening to the x and what's happening to the y, right? So when I go to fill this in, I'm going to say, well, my equation is y is equal to my k value, which in this case, k was 12, right? Because if I do 12 divided by 1, I get 12. If you want to write 12 over 1 here, that's fine. You can write 12 over 1. But just know that that's the same as if I wrote y is equal to 12x. Okay? So I have my equation. I have my table filled in. And this is how we do it. If I were to break this down into steps for you, I would say the first step would be to identify the two values and which one is y, which one is x. The second step I would say is actually identify what k is. In this case, k is 12 over 1, right? The third step, if you want, you can actually go right away and tell me what the actual equation is. Okay? And then the fourth step is you can apply that equation to fill in the data. Now remember, if you already have this and you remember that this is telling you that y is increasing by 12 and x is increasing by 1, then you could fill in your table just like that from step 2. But you want to be able to identify what's over what is y, what is x, fill it in on your table, start at 0, 0, then tell me what the constant is, right? Y over x from the information they gave you. They told me 12 an hour. That's 12 earned over 1 hour, right? So now I say, okay, y is increasing by 12, x is increasing by 1. I use that to fill in my table. Then I recognize, okay, that was the constant. I use that to tell me what the equation was. Y is equal to constant times X, Y is equal to 12 times X, right? Now I know this can be tough and I know this can be long. This is not an easy lesson, but I know that if you rewatch the video if you need to, I know you're gonna thrive and you're gonna get it. Thank you so much for joining me today. Once again, complete the rest of your work. I'm looking forward to seeing amazing work from all of my students. Have a great day. Until next time.